Today we are talking about translating descriptive form of parabolas and then also domain and range. And we're going to just kind of stop here for 1 second with domain and range. Who remembers what domain and range is? Okay, you are exactly correct. So domain is dealing with your x values and your distance of x values, how you were talking about, and your range is dealing with your y values and how many y values there are. Okay? So if you think about this, if we are talking about parabolas, and you know how our parabolas either like curve down or curve up, and how we have a minimum and maximum value. So let's say I had a parabola like this, and let's say here's the parabola. Can you guys see what I'm doing? Okay. So your domain on this graph, you know how you have the curve? Well, the curve is actually continually going out a little bit at a time. Does that make sense? So if you're looking at your x-axis and see how these curve, it'll keep going out, 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 out forever. Because when you have those little arrows, that means it goes on forever. So your x values are all real numbers because it will end up expanding to all of the numbers on the x-axis. So for instance, on this graph, my domain would be all reals, which we can do our little R thing there. Okay, but your range is dealing with your maximum and minimum values. Okay, so in this case, do I have a maximum or a minimum value? A maximum value because everything else is smaller. And what is that maximum value? -3. And it's on the x or y? Y. So if you look here, this is saying y is less than or equal to -3. Because all range values, all y values are smaller than -3. And so that's how you would describe your domain and range on these problems. So if you think about it, your domain on every single parabola is going to be what? All reals. And your range is the one thing that's going to change, and it's just going to change based on where your maximum or minimum value is. So this curve part right here, it's not like going straight down. It's curving. And so it will end up, if this went on forever, which it does, it would end up expanding to all numbers. And so either if it's curving down or curving up, it's going to keep expanding out. Okay? All right. Shifting graphs. There is these explanations here. I feel like this is more difficult. I think it's easier to sketch it and shift it and then write your new vertex with your new problem. So I'm going to show you the way that I feel is easiest. And then if you don't like the way that I'm teaching it, I can go back and talk about this, but I think you'll like the second way better. Okay, so here we go. Example 1. It says, if y equals x squared plus 6, and it is shifted down 3 units, what is the new equation? So what you want to do first is figure out what is your vertex of your original equation. So, what do you guys think? So our vertex, what values are with the x squared? What's being added with the x squared? Like here, if you did your parentheses like this? 0, right? Because x plus 0 squared is just going to end up giving you x squared. Do we agree? So really, this could be rewritten. We talked about this before. Y equals x plus 0 squared plus 6. So the x value of this vertex is 0, and the y value is what? 6. Okay, so I kind of make a graph, and I plot that point. So 0, 6 means I go up 1, 2, 3, 4, 5, 6, and make a point. Okay, from there it says now it's shifted down 3 units. So we're taking this vertex and we're moving it down 3. So 1, 2, 3. This is my new vertex. What is this ordered pair right there? That is at 0, 3. Yes. You don't have to, as long as you're getting the right answer. I think that graphing is your best bet, though, because you're able to kind of see what's happening. So this is my new vertex. So when I write that, we're going to get y equals, since the 0 for x is still there, you're going to get x squared. And then the y always stays the same number. So my new equation is y equals x squared plus 3. Okay, do we have any questions there? Okay, example 2. What do you notice right now about this equation? Y isn't by itself. So what would you think would probably be the best thing to do? Good. So we're going to add 3 to both sides. Okay, we're going to keep it in vertex form because it's in vertex form. We have y equals 2 parentheses x plus 5 squared plus 3. So what is my vertex on this problem? Not 5. Remember, whatever's in parentheses is the opposite. So that's negative 5, 3. So if we go make a graph, I'm going to go left 5 and up 3 and make a point. Okay, so now they're saying that they're taking this graph and it is shifted to the left 3 units. So from here, I'm going left 3 units. 1, 2, 3. So what is that new vertex? Negative 8, 3. So when we go to put it into this equation, we have y equals, the 2 stays how it is, and then instead of having x plus 5, I'm going to have what?
X minus 8.
No, not minus 8, it's going to be plus 8, because it's always the opposite for the x value, right? And then you still have squared, and at the end we still have plus 3. Now, for your answers, because the original one was like this, when you're like choosing your multiple choice answer, a lot of times they end up moving this 3 back to give you your new equation of y minus 3 equals 2 times x plus 8 squared. So most of the time, you want to end up putting your equation back to how it was originally in the problem. But is this wrong right here, the part in orange? No. This is just written 2 different ways. So if you know this is the answer and then you're looking at the answers and it's not there, we'll just see if you need to move something around to make it what the multiple choice answer is. Do we have questions so far? Okay, so look at example 3. I want you guys to maybe try this one on your own. I'll give you about a minute, maybe. And see if you can figure out what you need to do and how your equation changes. What is your original vertex on this problem? Good. There is nothing with the x squared, nothing being added at the end. So your original vertex is at 0, 0. Okay? I'm going to give you another minute or so to see if you can get it. Pay attention to like how your that is not your. You need to rewrite your equation. So the point, the vertex is right.
No.
No, x plus 3 squared.
X was 3 right there.
Yes, this is our notation that we usually
Okay, so let's see if anybody did this right. Okay, so it says that it shifted 3 units to the right. Do we all agree? 1, 2, 3 to the right. What is that ordered pair? No. It is 3, 0. At this point, x is 3, y is 0. Right? Okay, so this is dealing with the x part of the equation. Do we all agree with that? So when we are writing that in there, we have y equals, x isn't 0 anymore. So we're going to have our parentheses, and it's going to be squared. And if this is positive 3, what's going to go in here? Negative 3. And then I can put plus 0 if I want to, but we don't need to. Okay? And so this is your answer. That's it right there. How many of you got it right? Nice. Okay, those of you that didn't get it right, are we good now?
I don't know how to write it.
Have a hard time writing it?
Yeah,
So remember that your like kind of generic equation is y equals, and then you're going to have x plus or minus a number squared, and then you're going to have, you know, plus a number. Okay? This is where your vertex comes in. Okay? So right here, this is the x value of the vertex, and this is your y value of the vertex. This one, though, is always the opposite. Okay? So in this case, when you bring this 3 and put it in here, it's a negative 3 because it's always the opposite of what's in parentheses. Your y value is always just added to the end, whatever it is. In this case, it's 0, so you don't have to write it. If you go back to this problem right here, see how you had negative 8,3? So the x part is a positive 8, and then the y part was 3. So the y stays the exact same sign where the x one changes, because we'd end up setting it equal to 0, which changes the sign. Okay, is that a little bit? Okay, so do you guys want, so example 4, it's not really written in the correct form right now. So what would you do first to help you out with this? You would add 3 to both sides. So I'd get the equation as y equals 1/3 parenthesis x plus 2 squared plus 3. So then you're going to take that vertex, plot it, and then shift it. And let's go ahead. You guys try it again. When you get your answers, tell me, and I'll come check them. Okay.
Okay, the liquid is that the y value? I'm showing it, the negative 1, and then that just changes the sign. Perfect. And then you know that if this is always the x value vertex. So whatever's in parentheses is always opposite. So we're writing a vertex, the x value is going to be what? Now, want to write your vertex search there. And then y value is that.
Oh, yeah.
There's a vertex. So now the graph, you're gonna.
Well, I don't know about
the graph.
no, actually, it's positive. Oh, so it is.
And then I will make sure that I can put more.
What is beat?
Yeah, and I
Negative 2 positive 3.
No. I mean, like, once you have this, you get to be and you move this back and so
Yeah.
grab back this. So don't worry about it.
What is that point right there?
That is negative 2.
We're gonna go through right now.
It's negative 2,
Yes.
and you go.
Good.
So you go down 2, right?
Yeah, so let's talk about it.
Okay, let's see what's going on here. So, it's like half and half. So, what is my vertex on this problem? Negative 2, comma 3. Oh, Rome, you went down 3 instead of up 3. That's what happened. I'm like, we're doing something wrong. Okay. So, we mark this original vertex. Negative 2, left 2, up 3. 1, 2, 3. Make a point. Okay, so there is my original vertex. Are we all okay with that? Okay. Yes, we're good? All right. So now, 4 units down and 3 units right. So from this point, 4 down. 1, 2, 3, 4. 4 down and 3 to the right. 1, 2, 3. So what is that ordered pair right there? It is 1, comma, negative 1. So we're taking these numbers right here and putting them into this equation where the 2 and the 3 were originally. Yes.
But you said for earlier you said that the y equals 1/3 x minus 1, and the parentheses minus 1 and 2, that was right, but the 1/3.
Okay, let's see. Let's see. If I made a mistake, I apologize. Let's just check it out. So we're leaving all of this the same. So we're going to have y equals 1/3. And in the parentheses, what's going to happen with the x value? So it's going to be x minus 1 squared. And then the y value stays the same. So that's minus 1. So, yes.
Why is it inside negative?
Because remember with the x values, we would set it equal to 0. And then it would end up becoming x equals a positive 1. So whatever your x is here, when you put it in here, it's always going to be the opposite. Because when you set it equal to 0, you would end up getting back to the 1. So whatever's in parentheses is always going to be the opposite. Yes.
And I don't know if it's supposed to be.
Right. And so if we needed to switch this back, what would I have to do to switch it back?
Add 1.
You would add 1 to both sides. And then we would get y plus 1 equals 1/3 x minus 1 squared. So either one of those answers is okay. This one or this one. Okay, there's lots of talking. Does that mean you guys get this, or
We're teaching somebody.
do you guys want to ask me any questions before we move on? Yes.
I don't get when it's in the answer is x negative 1/3, right? Well, if you're getting the negative 1 and the positive 1, isn't the positive 1 an x? Isn't that in the x place?
Yes.
Why do you put it in the y?
I didn't.
But that's just all one comma. It's not x comma negative 1. It's just, no, on the answer. It's not x comma negative 1. It's just x negative 1.
Right. It's x minus 1. There's no comma. Are we good then?
Yeah, I didn't get why. I was like, why are you putting it in the y?
Okay. All right. Any other questions about this? Are we okay? And it's going to be just more practicing and looking back at your notes. Okay? All right, let's move to the next side. And we kind of talked about this already. Your domain, again, is your x values. Your range is your y values. So, on example 1.
Hold on a second. Can you go back and explain the report? She's just curious how, like, I tried to explain it the way you did it, but it's kind of hard for me. She's just curious about how you got the 1 formula.
Okay, so we're okay with this part right here? Okay, and then we're okay with shifting and getting this point? Yeah? Okay, do you understand why this is 1, -1 as the ordered pair? So remember that in ordered pairs, it always goes x and then y. So at this point right here, you went, because you always start like at 0, 0, and so you would go 1 to the right as a +1 for your x, and then you had to go down 1, which is a -1 for your y. So that's how we got that ordered pair of 1, -1. Okay? For your equations, when you're writing it, you are using this same equation that we started with. Okay? So I'm just going to rewrite this. So you're like going y equals, you keep the 1/3, you keep the x, you square it. And the only thing that's changing is these two numbers. Okay? So the numbers where you had 2 and 3, the graph was shifted, and these two numbers are going to change right here. So there's going to be a number put here and a number put here. Well, if you look, 1 is with x. Your x value always goes here, but it's always going to be the opposite sign. So if this is +1, when I put it in here, it's going to be a -1. If the x value here had been a -1, then I would have made this a +1. And the reason is because you end up, to get the x value, the vertex, you set this equal to 0, and then you would have to add 1 to both sides, and it makes a +1. So whatever's in the parentheses is always the opposite sign. And then your y value at the end stays exactly the same. The y value is not in parentheses. So that's how I get -1 here at the end. Okay? Just like here for this vertex. See how the x value is +2, but when I brought it out, it was a -2, and this 3 stayed a +3. So here, the 1 became a -1, and then this -1 stayed exactly what it was. Is that a little better? Okay.
Thank you.
You're welcome. All right, so back here, domain and range. We know domain is x values, range is y values. Okay? State the domain and range of the following. I believe it's sometimes easiest to state the domain and range by graphing it. Okay? What is your vertex on this problem? Very good. -2, -5. Because again, whatever in parentheses is the opposite, and then -5 at the end. So if I go and graph this, I would go left 2, down 5. Okay, is this graph going to be going up or down? Up. Okay. And we have our line of symmetry. Okay. So, my domain in this case, what is my domain values? So remember that domain is dealing with your x values. And remember how we talked about how the curve will just end up expanding all across all of the x values? So your domain is what? All reals. Okay. Your range, though, is dealing with your up and down values. Okay. So this is your range. Okay. So what point is this on my range? So, and then is it going... Are all the values bigger or smaller? So that means you're going to have a y is greater than or equal to -5. And that's your range. Those are your answers.
So all the domains are basically going
Greater than it's going up, less than it's going down. And this makes sense. All the values are bigger. This value, is it a minimum or maximum? Minimum, because everything else is bigger. Okay, example 2. I'm going to give you about 20 seconds for the whole thing.
Wait.
Maybe 30, maybe 40 seconds.
So the domain is all real, right? For what?
No, because I'm going to start really quick.
1. Oh, wait, it's 1.
You probably have it right.
Yeah. So then you go over -3.
Check with your neighbor once you do it. Check with each other and see if you guys agree with each other's answers.
No, you don't go. Oh, yeah, you did it. So then you can go.
Hopefully you don't have your phone out right now. You should be checking with the people you're sitting by, see if they have the same answers as you.
Yeah. Wow.
Tell them that they're wrong or right.
No, it's greater than.
Oh, it's 11.
Wait, don't say it. Negative.
On parabolas.
Wait, is it wrong to make all reals?
On parabolas, it'll be all reals. Okay, so did you guys all come to a conclusion? Do we all agree in our groups? So my vertex is what? Very good. -3, 0 is correct. So I go left 3, up 0. Is my curve going down or up? Down. Very good. Okay, so my domain, and for all parabolas, my domain's going to stay the same because they will all end up expanding over all x values. So what is my domain? All reals. What is my range value? What is my y at right here? 0. And is it going down or up? Down. So its y is less than or equal to 0. And those are your answers. Okay, questions? All right, example 3. This one is not written in vertex form. Do you guys remember how to find the vertex? What's our equation for finding the x value of the vertex?
Negative B over 2A.
Negative b over 2a. What is my negative b value?
Negative 20.
Negative 20 over 2 times
4.
negative 2, which is negative 20 over negative 4, which makes
Positive.
positive 5. So my vertex is at 5, comma, and then how do I find my y value?
Plug it in.
We take that and plug it in. We take 5, plug it in for x in that equation. So we have y equals negative 2 times 5 squared plus 20 times 5 minus 5. What's 5 squared?
25.
100.
And negative 2 times 25?
50. 25.
Negative 50.
Equals 45.
Plus 20 times 5 is
100.
100, and then another minus 5. So negative 50 and 100 is 50, and 50 minus 5 is...
45.
So my y value is 45. I'm going to count by 5s. Is that okay with everybody?
Yes.
So if we have 5 on the x, that means I go 5, and then we're going to go 5 on the x, and then 5, 10, 15, 20, 25, 30, 35, 40, 45 is 1 from the bottom. Is it going down or up?
Yeah.
Wait.
Okay, so what is my domain?
All real.
All reals. And my range is going to be what? Very good. Y is less than or equal to 45 because all the values are smaller because my curve is going down. Yes. Like why it's all reals. So again, see how like when you curve this, it's curving. It's not like it's a straight line. It's a curve, right? Well, this will keep curving and curving and curving and curving. You know, and when it's going to keep going out and out and out. And so what I mean by that is like, since these go on forever, at some point it will go out forever. So your domain is all numbers because at some point it will end up hitting all the numbers on the graph if you expanded it forever. It's going to be all reals for all of your parabola problems. When we have different shapes, it will change. But for this, that's it.